Children, today I'd like to discuss the second chapter in class 9. Is matter around us pure? Yes, all matter around us is not pure. Some are pure while some are impure. Pure substance like element and compound are the pure substance, and impure substance are mixtures, suspensions and colloidal solutions. Let us discuss the pure substance and impure substance. Pure substance is a such substance which is made of the same kind of substance, same kind of atoms. For example, sodium chloride. Sodium chloride is a pure substance and which is made of sodium ion and chloride ion. Similarly, the pure substance is a metal like iron. Iron is made of the same kind of particle, that is a iron particle. So that's why iron rod is an element. Now I'd like to discuss the mixtures. Mixture actually is the impure substance and which is formed by the more than two substance, but their proportion are not fixed. They can separated by the physical process, while as the pure substance like the sodium chloride is not separated by the physical process. So this is a basic difference between the pure substance and impure substance. Pure substance cannot be separated by the physical process, but the impure substance like mixtures can be separated by the simple physical process, simple physical method. Now let us discuss some impure substance like the mixture. There are two different type of mixture. First is the homogeneous mixture and second is the heterogeneous mixture. Discuss the homogeneous solution with a simple activity. Now we adding this salt in this water. We find that the salt, sodium chloride, is completely dissolved into water, and now we find that seems to be simply here water. No, this water containing salt like sodium chloride. So this solution is called to be homogeneous because the salt is completely dissolved into water, and in this water content the salt, sodium chloride are throughout available. So this is known as homogeneous solution. This is also called to be true solution because the salt is completely dissolved into the solvent. Salt is taken as a solute because here we are adding a small amount of salt in the solvent like water. So salt here act as a solute and water act as a solvent. Let us discuss the heterogeneous solution. Heterogeneous solution is a such solution in which the solute are not completely dissolved in the solvent. We find that when we adding some amount of soil in the water, we find that this soil are unable to completely dissolve, and after some time they are settled down at the bottom of this glass. So this is not a homogeneous solution, this is a heterogeneous solution, and heterogeneous solution is not look like a transparent solution, So it is a muddy water, so we can say that muddy water is a heterogeneous solution. Containing solution, glass B containing suspension, and glass C containing colloidal solution. Let us discuss the property of solution. We find that solution is a homogeneous mixture and their particles are smaller than 1 nanometer. So this is a very difficult to seen by our naked eye, and we already tell that their particles are are very small, so they cannot be separated by the filter paper, and they they are unable to scatter the ray of light. In the glass B containing a muddy water, and muddy water is a heterogeneous solution, and the particle or suspension can be seen by naked eye easily, and suspension can be able to scatter the beam of light when we pass ray, it having ability to scatter the ray, and solid particle are settled down when suspended particle is left. After some time we find that the particle will be settled down at the bottom of the glass. Now let us discuss the glass C, which is containing the colloidal solution, and colloidal solution is a solution, seems to be the homogeneous, but in fact it is a heterogeneous mixture. It is a heterogeneous solution. The size of the particle of colloidal solution is a very small, and it is a very difficult to see by our naked eye, and colloidal solution are big enough to scatter a beam of light passing through it and make its path visible. So we find that the particles are not settled down when left undistributed, and so that's why we can say that the colloidal solution is a quite stable solution. So this is a basic difference between solution, suspension and colloidal solution. We find that we can distinguish on the basis of Tyndall effect. We have already told that the Tyndall effect is a effect in which a ray of light passes through the solution, and this colloidal solution having ability to scatter the ray of light, and this is a first time told by Tyndall. So this effect is called the Tyndall effect, but the two solutions are unable to show the Tyndall effect. Let us discuss the concentration of solution. Concentration of solution can be represented by C. C is equal to N by V, and N is equal to number of solute and V is equal to the volume of solution. So concentration of solution is the amount of solute present in a given amount of solution. Now there are following three ways to express the concentration of solution. First, mass by mass percentage of solution is equal to mass of solute divided by mass of solution into 100. Second method is mass by volume percentage of solution is equal to mass of solute divided by volume of solution into 100. And third is volume by volume percentage by a solution is equal to volume of solute upon volume of solution into 100. So this is a three way to expressing the concentration of solution. Now I'd like to discuss the term solubility. What is the solubility? Actually, solubility can be expressed mathematically. Solute divided by solvent into 100 at given temperature is called to be solubility. We can define now solubility, actually the maximum amount which can be dissolved in 100 gram of solvent at a specific temperature is known as solubility of the solute in the solvent.